All right, now since we've gone through the Pythagorean identities for trigonometric expressions, we are going to use them to simplify trig expressions. So just a quick reminder, sine squared plus cosine squared equals 1, tangent squared of x plus 1 equals secant squared of x, and 1 plus cotangent squared of x equals cosecant squared of x. Those are our three trig identities. We're going to see if we use those for all the problems or if there's different ways to do these. Remember, there's not always one way. It's not my way is the highway kind of a problem. All right, so our first example is sine of x multiplied by cosine squared of x minus sine of x. So you've got a couple of choices. I do see that cosine squared term and sine squared plus cosine squared equals 1. So if I isolate the cosine squared, I'll have 1 minus sine squared. Okay, so that means that I can keep the original sign that's in the expression, replace cosine squared with 1 minus sine squared of x, and then subtract the other sine of x that's already there. Now we're going to use our distributive property. Sine of x multiplied by 1 is sine of x. Sine of x multiplied by a negative sine squared of x will give us a negative sine cubed of x minus sine of x that's there. And I have a positive sine of x and a negative sine of x adding together to give me 0, leaving me with just the negative sine cubed of x term. That's it. That's all we got to do to simplify. That, again, that's not the only way. There's another way. If you want to try it a different way and have it checked, by all means, do so. All right, example 2 has tangent squared of x minus tangent squared of x multiplied by sine squared of x. We've already got the identity, Pythagorean identity for sine squared, so let's jot down tangent squared of x plus 1 equals secant squared of x. Okay, got that guy. And now we just really kind of have to decide what is going to be our best route. So if I put tangent squared in terms of secant squared, then I'll have a secant squared and a sine squared. If I put sine squared in terms of cosine squared, then I'll have tangent squares and stuff. So I think what we're going to do is, I recognize that both of those terms have a tangent squared. So I'm going to factor out that GCF of tangent squared of x and see where it gets me for this example. So tangent squared of x is the GCF. Divide through the first term will give me 1. Dividing through give me the second term to be sine squared of x. All right, that looks a little bit better. Oh, hey, we just did that. In the first example, we said 1 minus sine squared equals cosine squared. So I can replace that quantity, 1 minus sine squared, with cosine squared. So now I have tangent squared of x multiplied by cosine squared of x. I'm not going to do a Pythagorean identity for tangent. I'm going to do a quotient identity for tangent. So I can write tangent as sine over cosine. So tangent squared is sine squared over cosine squared. That's multiplied by cosine squared of x. And then as we look through our example, we can see that we're multiplying and dividing by cosine squared. So they reduce, giving me just sine squared of x as the answer. Great job. Let's continue on. Here we go. Number 3, 1 minus cosine squared of x divided by cotangent squared of x plus 1. Okay, again, sine squared of x plus cosine squared of x equals 1. So if I subtract the cosine squared term, 1 minus cosine squared is equal to sine squared. I can replace that numerator with sine squared of x. The other identity that we have is cotangent squared of x plus 1 equals cosecant squared of x. So we can straight up replace the denominator with cosecant squared. Great, that was actually pretty easy. Now we just have to take care of this fraction. So I have sine squared of x divided by cosecant squared of x. Remember, cosecant is the reciprocal of sine. Okay, so you can write it a couple of different ways. I'm going to write sine squared of x divided by 1 over sine squared of x. And then I'm going to multiply through by the reciprocal of the denominator, giving me sine squared of x multiplied by sine squared of x over 1, which simplifies just to give me sine to the 4th power of x. Awesome. We are plugging and chugging along. Here we go, gang. All right, so in our next example, we have secant squared of x minus 1 divided by secant squared of x. Okay, I know we look at this and we go, oh, cool, I can cross off the secant squares. Well, no, not really. Right? That is a big no-no. However, we can actually still kind of simplify with that thought process, but I have to take the secant squared of x term and divide it by secant squared of x, and then I have to take the -1 that's in the numerator and divide it by secant squared of x. So you can use that thought process if you split that numerator into, or excuse me, split the fraction into two separate fractions being subtracted with the same denominator. Okay, because they have the same denominator. Good, so we can do that. It's not the only way. If you want to try something different, you sure can. Secant squared of x divided by secant squared of x is 1, and then minus 1 over secant squared. That is the reciprocal of cosine of x. So this would be cosine squared of x. Awesome. We've simplified this down to be 1 minus cosine squared. Lo and behold, guys, we already used that. 1 minus cosine squared is sine squared of x. And you're done. Now, we're getting sine squared, sine cubed. As a lot of the answers so far, it's not always the answer. Don't think that it is. Okay, number 5. Number 5 is cotangent squared of theta minus cosecant squared of theta. Simplify that guy. All right, our identity with cotangent is cotangent squared of x plus 1 equals cosecant squared of x. Okay, so I can go ahead and substitute cosecant squared in the formula with cotangent squared of x plus 1. We can do that. You could also isolate the cotangent squared term and replace it with cosecant squared of x minus 1. Okay, you could do that as well. Or we could just kind of manipulate it again and get what I want it to be. I want it to be a cotangent squared minus a cosecant squared. So if I isolated cotangent by subtracting 1, then I can actually subtract cosecant squared from cotangent squared and make it equal -1. That's it. That gave us exactly what we wanted. So all we did was manipulate that trig identity, that Pythagorean identity, to get the answer. Now, if you had done one of the other ways, it would have worked out. Let's pick the second one right here. So cotangent squared is cosecant squared of x minus 1. So if I replace that first term with cosecant squared of x minus 1, and then it's minus the cosecant squared of x, or theta, excuse me, yeah, those cosecant squared terms are going to simplify when we combine them to 0, giving us -1. Or if you had done it with the cosecant squared term replacing with cotangent squared of x plus 1, that would have given you the same thing. Great work. We are plowing through. All right, number 6, 1 minus sine squared. All right, my identity with sine squared, that Pythagorean identity, sine squared plus cosine squared of x equals 1. If I subtract sine squared from both sides of the equation, I get cosine squared isolated. So 1 minus sine squared is cosine squared. We're done. I love it. I love when we get super easy ones just to practice and see how we can use these identities. All right, number 7, secant squared of x minus tangent squared of x plus cotangent squared of x. Okay, we got a lot going on here. We can change them all to be the tangent and cotangent could be reciprocals. Secant could be written, or excuse me, those are quotient identities. Secant would be a reciprocal. We can also do Pythagorean identities. We do have a Pythagorean identity with secant squared and tangent squared. Let's work with that one. Tangent squared of x plus 1 equals secant squared of x. So if I subtract tangent squared on both sides of the equation, I'll get 1 to equal secant squared of x minus tangent squared of x. Perfect. That's exactly what I needed. So those first two terms of this expression simplify to give me 1, and then I just have 1 plus cotangent squared of x. All right, well, that's another trig identity. Remember, cotangent squared of x plus 1 equals cosecant squared of x. I'm loving these Pythagorean identities. They're great. So I can straight up replace 1 plus cotangent squared with cosecant squared. That's our answer. Okay, good job, guy. We got this. Alrighty, number 8. Tangent of x multiplied by cotangent of x minus sine squared of x. Now, we can change tangent and cotangent several different ways, but remember, tangent and cotangent are reciprocals. I should write and, actually. And if we multiply reciprocals, we should always get an answer of 1. I'm going to do what most of us would do, and we would change tangent and cotangent to be in terms of sine and cosine because we have a sine squared term. So let's just do that and prove to ourselves that sine over cosine multiplied by cosine over sine will simplify. All right, then minus my sine squared. So if I multiply the two numerators, I get sine of x, cosine of x. If I multiply the denominators, I get cosine of x, sine of x. Guys, those reduce, giving you 1. So we have 1 minus sine squared of x. That's the Pythagorean identity, sine squared plus cosine squared equals 1. So that means that 1 minus sine squared is equivalent to cosine squared. Awesome. We are nearing the end, and we are doing great. Number 6, cotangent of x multiplied by the quantity of cosecant squared of x minus cotangent squared of x all over cosecant of x multiplied by secant of x. All right, that is a lot. Let's take it piece by piece. Let's keep cotangent just like it is for right now. Let's look at the next identity. Remember, our identity for cotangent is cotangent squared plus 1 equals cosecant squared. So if I subtract the cotangent squared to the other side of the equation, I'll have 1 equal to cosecant squared minus cotangent squared. Oh, that's awesome. Great. I can replace that entire term in the parentheses with 1. Cool. Let's just do that. We'll look at the rest of it in a minute. So cotangent of x multiplied by 1, guys, that's just cotangent, divided by cosine of x multiplied by secant of x. Okay, so let's work with our denominator since we've got 2 terms down there. Remember, secant and cosine are reciprocals. So if you want to write this as cotangent of x divided by cosine of x multiplied by its reciprocal, 1 over cosine, that will prove to you that when we multiply the reciprocal identities, or any reciprocals, they're going to give us either 1 or negative 1. Okay, so that simplifies to give me cotangent of x over 1, which is just cotangent of x. Awesome. That one looked really bad, and it turned out to not be that bad. All right, number 10, secant squared of x plus tangent squared of x, or excuse me, secant squared of x multiplied by tangent squared of x plus secant squared of x. Our identity, tangent squared of x plus 1 equals secant squared of x. So if we have secant squared, we can replace it with a tangent squared of x plus 1. We're welcome to do that. Another thing is we could put things in terms of tangent squared. So tangent squared of x would equal secant squared of x minus 1. We could do that. That's a choice. Another choice is go back to our algebra skills. What do we have in both terms? That's right, we have a common factor of secant squared. Some people are going to jump right to that. Some people are going to jump to using the identities the other way. I'm going to show you the secant squared way with the GCF, and then we'll see if we have time for another way. So I'm going to factor out that common factor, secant squared of x, leaving me with a tangent squared of x plus 1. Secant squared divided by itself is 1. Tangent squared of x plus 1 is secant squared. We have that identity up at the beginning. So this is secant squared of x multiplied by secant squared of x, giving us secant to the 4th power of x. Awesome. We did it. All right, now I'm going to show you another way, just in case somebody did it differently. I'm going to use the one where I'm replacing tangent squared with secant squared minus 1. So this would be secant squared of x multiplied by the quantity of secant squared of x minus 1, and then plus the secant squared of x that's already at the back end of that expression. Then I'll use distributive property and combine my like terms. Secant squared multiplied by secant squared is secant to the fourth of x. Secant squared multiplied by negative 1 is a negative secant squared of x. And then I have the positive or plus secant squared of x. And those two terms are exact opposites, so when I add them together, they're no longer there, leaving us with secant to the fourth power of x. Great work, gang. Make sure you're practicing. Come on in if you need help, have any questions.